Hey there, dreamers! Welcome to Debugger Dreams, the space where we untangle the fascinating threads of technology and bring your coding dreams to life. Whether you're a seasoned developer, a coding enthusiast, or someone who's just dipped their toes into the vast ocean of zeros and ones, you're in for a treat. Debugger Dreams is not just a channel, it's a community of tech dreamers, and you, my friend, are an essential part of it. Without further ado, let's begin. The history of computer science, ancient foundations pre-19th century. Ancient foundations pre-19th century of computer science find their roots in the ingenious methods devised by ancient civilizations for numerical calculations. The earliest known tool for arithmetic computations is the abacus, which dates back thousands of years and was widely used in ancient China, Mesopotamia, Egypt, and other cultures. The abacus represents a fundamental concept in early computational thinking, enabling individuals to perform basic mathematical operations through the manipulation of beads or stones on rods. Additionally, ancient mathematicians such as the Greeks and Egyptians laid the groundwork for geometric and algebraic principles, contributing essential ideas to the mathematical foundations of later computational developments. While these early technologies were far from the complex electronic systems we recognize as computers today, they represent the initial steps in humanity's quest to mechanize and streamline the process of calculation, setting the stage for the remarkable advancements to come in subsequent centuries. 19th century, the mechanical era. The 19th century marked a crucial phase in the history of computer science known as the mechanical era. During this period, visionary mathematician and engineer Charles Babbage conceptualized the analytical engine 1837, a groundbreaking mechanical device designed to perform complex calculations through the use of punched cards. Babbage's analytical engine is considered a precursor to modern computers, featuring fundamental concepts such as a stored program, conditional branching, and a central processing unit. Although Babbage was unable to build the analytical engine due to financial constraints and technological limitations of the time, his visionary ideas laid the theoretical foundation for future computing machines. The mechanical era also witnessed other notable advancements, including the work of Ada Lovelace, who collaborated with Babbage and is credited with writing the first algorithm intended for implementation on a machine. Despite the lack of practical realization during this era, the seeds planted by Babbage and Lovelace set the stage for the electronic and digital revolutions that would follow in the 20th century. Early 20th century electromechanical systems. In the early 20th century, the field of computer science experienced a pivotal shift with the advent of electromechanical systems. During this era, punched card systems emerged as a crucial technology for data processing and information storage. Notably, these systems played a vital role in the 1890 United States Census. Concurrently, the visionary engineer Conrad Zuse made significant strides with the creation of the Z3 in 1941, considered by many as the world's first programmable digital computer. The Z3 utilized electromechanical components and marked a crucial step toward the development of electronic computing. These electromechanical systems laid the groundwork for subsequent innovations, demonstrating the potential for automatic computation and paving the way for the electronic era that followed during World War II. World War II, the electronic era. World War II marked a pivotal period in the history of computer science, known as the electronic era. The conflict drove an urgent need for faster and more efficient computation, leading to the development of electronic computers. Notably, the Colossus, developed in Britain in 1943, was one of the first programmable digital computers designed for code-breaking purposes. Meanwhile, in the United States, the ENIC, Electronic Numerical Integrator and Computer, emerged in 1946, showcasing the power of electronic computation for military calculations. These machines represented a shift from purely mechanical to electronic systems, setting the stage for the post-war era of computing. The wartime focus on electronic computing technologies significantly accelerated progress and laid the foundation for the subsequent rapid advancements in digital computing during the post-war years and beyond. 1950s, the birth of computer science as a discipline. The 1950s marked a crucial period in the evolution of computer science, witnessing the formal establishment of the discipline as a recognized field of study. This era was characterized by a convergence of theoretical and practical developments that laid the intellectual foundation for computing. The introduction of high-level programming languages such as Fortran in 1957 and Lisp in 1958 allowed for a more abstract and efficient expression of algorithms, fostering the growth of software engineering. Notably, the publication of Alan Turing's seminal work Computing Machinery and Intelligence in 1950 spurred discussions on artificial intelligence and the nature of computation. Academic institutions began offering computer science courses, and the discipline gained institutional recognition with the establishment of computer science departments in universities. This period set the stage for the systematic exploration of algorithms, computational theory, and the broader implications of computing, shaping the academic landscape and defining the core principles that continue to guide computer science today. 1960s, mainframes and minicomputers. The 1960s marked a pivotal era in the history of computer science with the widespread adoption of mainframe computers and the introduction of minicomputers. Mainframes, exemplified by IBM's System/360 series, revolutionized large-scale data processing and business applications. These powerful machines were characterized by their reliability, high processing speeds, and centralized control. The versatility of mainframes allowed organizations to handle complex computations and manage extensive databases, making them crucial for industries such as finance, government, and research. Concurrently, the development of mini-computers like the Digital Equipment Corporation's DEC PDP-8 brought computing capabilities to a broader audience. Mini-computers were smaller and more affordable than mainframes, making them suitable for research institutions, laboratories, and smaller businesses. The combined influence of mainframes and mini-computers during this decade laid the groundwork for the diverse computing landscape we have today, contributing to the democratization of access to computational power. 1970s, microprocessors and personal computers. The 1970s marked a pivotal era in computer science with the advent of microprocessors and the dawn of personal computers, PCs. In 1971, Intel introduced the first microprocessor, the 4004, which condensed the essential components of a computer onto a single chip. This breakthrough paved the way for the development of affordable and compact personal computers. The iconic Altair 8800, released in 1975, became one of the first commercially successful microcomputer kits, inspiring enthusiasts like Bill Gates and Paul Allen to develop a programming language for it, Microsoft BASIC. The following year, Apple Computer was founded by Steve Jobs, Steve Wozniak, and Ronald Wayne. In 1977, the Apple II was introduced, featuring color graphics and an open architecture, making it one of the earliest fully assembled and functional personal computers available to the public. The microprocessor revolution democratized computing, empowering individuals and small businesses, setting the stage for the widespread adoption of personal computers in the subsequent decades. 1980s, graphical user interfaces and networking. The 1980s marked a transformative era in computer science with the widespread adoption of graphical user interfaces, GUIs, and advancements in networking technologies. Apple's introduction of the Macintosh in 1984 and Microsoft's Windows operating system in 1985 revolutionized the way users interacted with computers. GUIs replaced command-line interfaces with intuitive, visually driven interactions, making computing more accessible to a broader audience. Concurrently, the expansion of networking technologies, particularly the standardization of the Internet Protocol, TCP/IP, laid the foundation for the global connectivity we recognize today. These developments paved the way for the emergence of the World Wide Web in 1991, enabling seamless information exchange and collaboration. The 1980s, therefore, stands as a pivotal period where the user experience was elevated through GUIs and the groundwork for the interconnected digital landscape we navigate today was established. 1990s, rise of the Internet and mobile computing. The 1990s marked a transformative era in computer science with the explosive growth of the Internet and the advent of mobile computing. The World Wide Web, introduced by Tim Berners-Lee in 1991, revolutionized the way people accessed and shared information. This period witnessed the popularization of the Internet, bringing about a connected global community. E-commerce platforms emerged, changing the landscape of business and commerce. Additionally, the proliferation of mobile computing gained momentum with the introduction of laptops and the release of the first smartphones. Mobile devices became increasingly powerful and accessible, enabling individuals to connect to the Internet on the go. This convergence of internet and mobile technologies laid the foundation for the interconnected, digitally driven world we experience today, shaping communication, commerce, and social interactions on a global scale. 21st century cloud computing and artificial intelligence. In the 21st century, two pivotal trends, cloud computing and artificial intelligence, AI, have played transformative roles in reshaping the landscape of computer science. Cloud computing has revolutionized the way data is stored, processed, and accessed by offering scalable and on-demand computing resources. This paradigm shift enables businesses and individuals to harness powerful computational capabilities without the need for massive infrastructure investments. Concurrently, artificial intelligence has experienced unprecedented growth, leveraging advanced algorithms and machine learning techniques to process vast amounts of data and derive valuable insights. AI applications ranging from virtual assistants to autonomous vehicles have become integral parts of our daily lives. The synergy between cloud computing and AI has fueled innovation across industries, facilitating the development and deployment of sophisticated and scalable AI solutions. This integration has not only enhanced computational capabilities but has also paved the way for groundbreaking advancements in fields such as natural language processing, computer vision, and data analytics, shaping the trajectory of technological progress in the 21st century. Present and future. In the present era, computer science stands at the forefront of technological advancements, playing a pivotal role in shaping various aspects of daily life and industries. Cloud computing has become ubiquitous, enabling flexible and scalable solutions for businesses and individuals alike. Artificial intelligence, AI, continues to evolve, with breakthroughs in machine learning, natural language processing, and computer vision driving innovations in areas like autonomous vehicles, healthcare, and personalized services. Quantum computing, although still in its infancy, holds the promise of revolutionizing computational power by leveraging the principles of quantum mechanics. Cybersecurity has become increasingly critical in the face of growing digital interconnectivity, and efforts to enhance data privacy and security are ongoing. As we look to the future, the trajectory of computer science appears poised for further transformative breakthroughs, with the potential for advancements in quantum supremacy, AI ethics, biotechnology integration, and the continued evolution of the Internet of Things, IT, contributing to a technologically dynamic and interconnected world. Well, dreamers, that's a wrap for today's adventure in the Debugger Dreams universe. I hope you had as much fun exploring the history of computer science as I did. If you enjoyed the ride, don't forget to give that like button a little love. It helps us keep the dream alive. See you later.